Hello, you're welcome to this lesson. In this video, we are going to solve this question I have here on the screen, which is a question asking us to find the resultant force and then the direction of the resultant force. So the question says that the screw I in the figure below is subjected to two forces, which is F1 and F2. Determine the magnitude and direction of the resultant force. So we have two forces here, which is F1 and F2. Okay, so we have to determine the magnitude of the resultant of what these two forces. The magnitude of the two forces is just like the total force. Okay, so you see that over here we have two separate forces, which is F1 and then F2. So the resultant force is just the sum of these two forces here. But when you look at these two forces, you see that they are vectors, they have magnitude and then direction. So in this case, you see that it is in a two-dimension form, so they are going to have x and y components. So we can't just add these two forces directly. We will have to resolve them into their x and y component. Then we add the components separately. Then we take their magnitude, and then that will give us the magnitude of the force. So let's go ahead and then look at how we are going to do this. So first of all, I'm going to resolve the two forces into their components. Okay, so I'll first consider F1. Okay, so let's look at how that is going to be. So I'm going to draw a free body diagram here. Okay, where I will consider only F1. So we have F1 here, which has a magnitude of 100 Newton. And then it makes an angle of what 15 degrees with the positive x-axis. So now this F1 here will have component, which is the x component and then the y component. Okay, so this is the x component and then this is the y component. So we need to find the x and then y component of this force. So let's look at how we are going to do this. So when I take cosine of this angle, which is cosine of 15 degrees, okay, that's going to be the adjacent side over the hypotenuse. And you know the adjacent side is the fx. Okay, so I'm going to have f sub x divided by the hypotenuse, which is 100 Newton. And I want to find the x component, so I'm going to make f sub x the subject. So you have f sub x equals 100 cosine of 15 degrees. Okay, so this will be the x component of this force. And then similarly, you are going to do for the y component. So for the y component, I'll take the sine of the angle. So that will be the sine of the angle 15 degrees. That will be equal to the opposite side over the hypotenuse. So you see that the side which is opposite to the angle is the f sub y here. So that's the opposite side divided by the hypotenuse. So I'm going to have f sub y to be equal to 100 sine of 15 degrees. So this is for f1. Okay, so for f1, okay, let me do it like a table. Let me name this the forces. Okay, and then name this the x component, which is measured in Newton, and then the y component, which is also measured in Newton. Okay, so let's have this table here. So I have f1 here. So for f1, for the x component, we have 100 cosine of 15 degrees, and then for the y component, we have 100 sine of 15 degrees. Okay, so I'm going to do the same for f2 also. So let's look at how I'm going to do that. So I'm going to draw a free body diagram for f2 only, and then we will find its components. Okay, so we have f2 here, which has a magnitude of 150 Newton. Okay, And then it makes an angle of what 10 degrees with the vertical axis, which is the y-axis. So we need to find the x and y component of this f2 here. Okay, so let's look at that. So we're going to have this to be the x component, and then we're going to have this to be the y component. Okay, so you have the y component here, then you have the x component here. So this will be fy, okay, and then this will be fx. So now let's find the x and y components of this force. So let's take the cosine of the angle. Cosine of 10 degrees, okay, that would be the adjacent side over hypotenuse, right? So that would be fy over 150. Okay, so we are going to have fy to be equal to 150 cosine of 10 degrees. And then I'm going to do same for fx. Okay, so let's take sine of the angle. So sine of 10 degrees, okay, will be equal to the opposite side, which is f sub x over hypotenuse, which is 150 Newton. So I'm going to make fx the subject, and then I'm going to have 150 sine of 10 degrees. So you now know the x and y component of f2 also. So let's write down here. So for f2, we have the x component to be 150 sine of 10 degrees, and then y component to be 150 cosine of 10 degrees. So we have this here. So now all you have to do is to sum the components separately. So I'm going to sum all the x components, and then we sum all the y components also. Okay, so let's sum everything up and then see what you get. So we have for the x component, you're going to have 100 cosine of 15 degrees plus, okay, plus 150 sine of 10 degrees. So this will give me 122.6. Okay, so let's do the same for the y component also. So I'm going to have 100 sine 15 plus 150 cosine of 10. Okay, so that also give me 173.6. So now we know the x and y component of this resultant force. Okay, so we can go ahead and calculate for its magnitude. So let's go ahead and then look at that. So then take this to be the resultant force. Okay, so for the magnitude of the resultant force, that's going to be the square root of the sum of the components. So we're going to have 122.6 squared plus then 173.6 all squared. Okay, so let's simplify this and see what you are going to get. So 122.6 squared plus 173.6 squared. Okay, this will give me a value of I have 45167.72. Okay, so let's take the square root of that value and see what you will get. So that gave me a value of 212.5. Okay, 212.5 Newton. So that will be the magnitude of the resultant force. So now what do we do next? What you have to do now is to find the direction of the resultant force. You see that F1 has a direction and then F2 also has a direction, okay, which is the angle they make with the x-axis and then the y-axis. So you have to find that same angle for the resultant force also. So let's go ahead and then look at how we are going to do this. So I will go ahead and then free up some space so that we look at how to calculate the direction of the resultant force. Okay, so I think we have enough space now. So let's go ahead and then calculate for the direction of the resultant force. So when you look at the components of the resultant force which you have here, let me indicate it here. So look at the component that you have here. You see that they are all positive. Okay, the components are all positive values. The x component is positive, and then the y component is also positive. So that means that when you make a plot, it is going to be in the first quadrant here. Okay, so you're going to have the resultant force here. Okay, so this will be the resultant force. So now all we need to do is to calculate for this theta here, which is the angle that it makes with the positive x-axis. Okay, so let's go ahead and calculate for that angle. So we know that if you have the resultant force here, you're going to have the x component to be here, then you're going to have the y component to be here. Okay, so I can take the tan of the y component over the x component. Okay, then that's going to give me the angle. Okay, so that's going to be something like tan theta, okay, will be equal to the y component over the x component, right? Because tan is opposite over the adjacent side, right? And then this is the opposite side, and then this is the adjacent side. So that's what we have here. So we're going to have tan theta to be equal to, we know the opposite side to be 173.6, and then the adjacent side to be 122.6. So let's simplify this and see what we are going to get. So 173.6 divided by 122.6. So that gives me a value of 1.41. Okay, let's make this 1.42. Okay, so let's find the tan inverse of that value. That's going to give us tan inverse of 1.42. Let's see what we get. Okay, so tan inverse of 1.42 gave me a value of 54.8 degrees. So that would be the angle that the resultant force makes with the positive x-axis. So that's all for this video. Thank you very much for watching. Please make sure you like and subscribe. And if you don't understand anything in the video, please make sure let me know in the comment section.